Okay, I guess we just get started. My name is Daniel Arndt, and together with Nathan, who sits right over there, I'll present on Kokkos' approach to continuous integration, with maybe a little bit more than CI, what people think normally of CI. So briefly, Kokkos, if you have not heard of it, is a performance portability C++ library. So I have here one of our iconic pictures. Basically, we have applications on the top, then Kokkos is a performance portability layer, so you just write Kokkos API, and then you can run performance portable on all different architectures that we care about. So like this is slightly outdated, but still like represents today's supercomputer architectures pretty well. And so that motivates a little bit the challenges that we're facing. We have like a fair amount of configuration options. We strive to support everything that can be found in common setups on laptops up to supercomputers, from like very low compiler versions to the newest, best and greatest. And so that means we need to test a ton of compilers and compiler versions. Then we, of course, have a lot of backends, so everything you need to run on the supercomputers, on the host, and then we also have like some more experimental backends like OpenACC and NextSilicon. Build types, we have the classical CMake ones, where like some debugging options play a role, and then the architectures, of course, like everything that you might encounter, in particular also consumer grade hardware or whatever a user is interested in, we try to support. And then, of course, other configuration option, relocation device code, deprecated code, legacy view, all kinds of different things, some a little bit more backend specific, like if you want to use a memory pool or whatnot. So accommodating all of that, this is a really difficult task, and we have to choose how we do this because we don't have infinite resources. So the talk is basically structured in 3 parts. So we have continuous integration. Then we want to talk a little bit about nightlies and then integration testing. That's why I said it's not quite continuous integration. From the evolution point of view is like up to 2019, we didn't really have much in CI. There was kind of like a spot check going on coming from Trilinos, so we had like some people running stuff. But then after ECP, we really ramped up now, and HPSF helped a bunch with that, so that we are now running around 60 builds for every commit. Distributed across multiple providers and institutions, and also have a working group for that. So we started out in 2019, adding some Jenkins testing at ONL, which was good, but with limited resources. In 2020, we moved then to GitHub with GitHub runners to support some more of the host architectures, more nightly tests. And then 2024 really ramped up that we had all our institutions participating to Kokkos, providing some kind of CI, also representing a little bit more the interest in particular builds. So we have like CEA and then NERSC also patching in a little bit. And then we also founded the CI working group basically after the HPSF working group was founded. And so this is now really working well for us. And so let me get a little bit more into the details. So what we're doing right now is we're running around like 30 builds on the CPU, and then another 26 builds or so on the GPU, and you see that like all our host builds are basically covered by GitHub. There's of course nothing on the right-hand side, and only like some special builds then covered also on CPUs. And so this is quite nice for us that we can test across a wide variety of hardware. Let me get a little bit more into the issues and specific setups that we're using. So you see on Jenkins, we have like a C++20 build, but then we test like a lot with CUDA. architectures, so OpenACC, CUDA, and then also SYCL on NVIDIA GPUs, and we have some HIP builds. So what we're missing here specifically is Intel GPUs. And issues we're running into here often is like updates that are out of our control, like the nodes need to be rebooted or updated without our notice, and then we run into driver library mismatches, which are hard to detect. Disk space limits and cleanups are somewhat of a problem, and we don't have visibility super well into these specific runners, which might work, which might be a problem or not, because the architectures might not match up perfectly. And one of the most problematic things is that this takes long because we have small capacity machines, just because the amount of money that we can throw into that is somewhat limited. Then on the HPSF side, we have like the latest and greatest, more or less, which is nice. So we talked about that before, and in fact, University of Oregon provides a DGX Spark, which we just recently added. And otherwise, we have like all the other classical stuff, like MI300As with a bunch of builds on Intel hardware now, Grace Hopper and Grace. So this is really nice to flesh that out, whatever's upcoming, and we're very grateful that this works well. The problems here is we don't have control over the hardware, so we have to trust that whatever the University of Oregon is doing works well. So oftentimes if something breaks, there is no really good point of contact. I mean, we need to just like reach out to specific people. That's maybe something that could be worked on. And so we don't get like maintenance notifications or like notifications about, hey, the system is not working. Don't expect your CI to work. And as mentioned before, we don't have like proper job separation. So sometimes we have like builds that are running, that are timing out unexpectedly because some other users is currently using the hardware, and that makes it really hard to track that down. And lastly, of course, this requires a GitLab mirror, which makes the setup a little bit harder. But in the end, I mean, this works like with this kind of hubcast integration also pretty well. Okay. Then we have Sandia. Sandia helps us a little bit out with bigger machines, so that's like one of our fastest running CI, at least faster than the Jenkins one at ONL. And again, here we are covering major architectures and have like also builds for HPX, which is a little bit unusual. And we recently did Next Silicon. We try to have redundancy for everything, but we noticed that this is like the only build type with like a specific build option. And I mean, surely enough, when this CI failed, because I mean because it has like internal issues at Sandia, infrastructure issues, surely enough, of course, we broke that build. So it's really important to have this redundancy, which we failed to do a little bit here. So Sandia. The Sandia tests depend a lot of in-house software. So like whenever like their mirror or the image server is down, then everything is down and we can't do anything. So again, we don't really have control over the machines at all. Like we need to rely on the Sandia hardware team. And it's also a little bit annoying in terms of testing pull requests because Sandia is more concerned about cybersecurity here, so you really need to be on a particular list to approve pull requests, whereas like otherwise it just works. Like we allow for all other CIs to immediately run without much issues. So yeah, it just requires more buy-in, which I mean, this is less of a problem if basically all of your contributors are from that same institute. But I mean, and then I mean for Trilinos that works well, but that's not the case for Kokkos. And so this is something that hinders us quite a bit, or I mean, it's just annoying. Anyway, finally, the GitHub stuff. The GitHub hosted runner are fairly extensive, running on different architectures, more consumer grade, so laptop kind of architectures. We have builds for ARM, so for Mac architectures, and then that's also the only ones where we have Windows. And all of these use containers that we store ourselves. So we just build that environment and store that in a separate GitHub repository, which is a nice setup that can also be used across multiple Kokkos projects. Issues here is, of course, again, we have like small machines. It's only CPU builds, but I mean, that's kind of offset by by all the other builds that we can use. And of course, everything is ultimately tied to GitHub. Like all the pull request reporting, even from the other CI providers, show up in GitHub. So if that has issues, we don't see anything, basically. So that's why GitHub also plays like the most central role for us, really. Yeah, in terms of nightly tests, as I said before, we have like all other institutions patch in here a little bit. So we also run on the supercomputers in particular. So you can see here ALCF, OLCF, and NERSC, which didn't show up. CEA provides some nightly builds. And then, yeah, we also have a bunch of things on the CPU side, but not as much. And basically, everything on the nightly side we can see in CDash, where we use like all the different dashboards, which is nice. And as I said before, it's more like new and experimental and exotic builds, expensive builds. I put in some screenshots, but I'm not quite sure if that's visible. Is that like good generally? Can you kind of read what's on there? Okay, perfect. Yeah, so we can see here that we are, for example, then are finally testing on Argon machines with the data center Max 1550. We see different other providers. We see here that we also have like some spec builds. So that's like something that we check like weekly or so, which is nice. And so this is nightly, so it's for nightly builds. And then for continuous, we report everything from our HPSF CI there. So that's what we, whenever we have like a merge commit, we do that. So you see the same builds here. And finally, for the experimental, that's like all the builds from the pull requests on the HPSF side. They are also listed here. So this is kind of like a backup to our GitHub setup, at least for that kind of CI type. And well, I mean, like a nice feature here is that you have like this GitHub GitHub icon. If you set like the build ID correctly in your CDash submission, that you can directly go back to GitHub. So that all works fairly well. And if you just want to see, okay, what's like the current status of all the pull requests, that's a easier way to do that rather than maybe to go through all the pull requests, or if you know you're interested in something in particular. And yeah, I mean, the last piece here is the integration testing with Trilinos. So Trilinos is, of course, very important in Kokkos history. So first of all, I mean, probably all know Trilinos is a high-performance scientific computing library, distributed linear algebra solvers and discretizations, and Kokkos originated from Trilinos, and would then be its own package in like the 2010s or so, and in the end then just became a separate project. But that also means that Trilinos uses Kokkos quite a bit and ties into Kokkos internals quite a lot. which means it's very important for us to test with that like that's the best measure if we would break someone. In particular, also, I mean, like people are getting Kokkos through Trilinos, and the most use cases can probably be found there. Also, Kokkos doesn't really have a good performance tracking solution yet, and so at least tpetra gives us a good idea of what they are seeing as a proxy when Kokkos is breaking something, and that motivates also why integration testing is very important. Of course, configuring in Trilinos is even more problematic, I mean, in terms of coverage than in Kokkos. Much more configurations options, so whenever we do something, we need to be very selective. So there were some extensive jobs where we try to enable a lot of packages, some selective, some application specific. And the issues here, of course, that we need to track 3 different development branches, which is Kokkos, Kokkos kernels, and Trilinos. And benefits are, of course, that we avoid compounding breaking changes. So we started that also fairly, well, I mean, a couple years ago, but that was an important step for us in our CI. As I mentioned before, issues are again around cybersecurity. Here even more problem than just running our CI, because most Kokkos developers cannot even access djenkins or the dashboards where all of that, the integration testing is reported. So we basically rely on individual people to have a look. And like breaking free of that would be really nice. In terms of what we're testing, we have a bunch of examples here. We have extensive testing on the host side, and then CUDA architectures and HIP architectures that are extensively tested, and we also see that we cover all 3 major GPU architectures, so we also have an Intel One API build. On top of all of that, we have a snapshot testing, which is a little bit different from the nightly testing, in that we just plug it in to Trilinos. In the Trilinos repository as a pull request itself, which allows some more extensive testing. But yeah, all that is to say, this works now really well for us, and generally we like all feedback that we can get from other users, from downstream projects. We are happy to work with them also in the CI working group to see if we can set that up, that we can monitor more applications downstream, which might require a little bit more buy-in from them, because, I mean, in the end, everyone benefits, so we can, as Kokkos, discover problems earlier, and of course, then downstream apps also ensure that we take their problems into account earlier. So whenever we are very grateful if people can just report any kind of incompatibility or problems to us. Yeah. Finally, as a summary, we have seen that the redundancy is very important. We have seen if we just, when Sandia CI was failing, there was kind of hidden to us that was the only provider enabling a specific options, and surely enough, we broke that, and we see all other CI providers are somewhat unreliable. We never really have control over the machines, and even if we have, there's a lot of burden to always keep everything up. So we're pretty happy with like having for every build kind of a good proxy representation, and we think this is crucial for having somewhat reliable CI. Also, the integration testing proved to be very useful, and in the end, it's a huge burden to cover CI in your general development. If you have a big enough team, like for Kokkos, it really helped us to have a dedicated working group looking at issues like every 2 weeks or so, or generally taking care of that instead of instead of putting a burden on all the other people. So with that, we are available on Slack, and we have a CI working group info. And I'm happy to take questions.
Hey, it sounds like some of your pain points could be addressed by better communication. Oh, I won't address that, but have you found yourself kind of writing sanity checks in CI to check for things like, oh, the mirror's down, oh, these packages have been upgraded, or is it that the failure modes are so diverse that it's better to just go look at build and test logs?
Can you rephrase it a little bit? So you're asking if failure modes are in general diverse, or that like different like issues that we're seeing across providers are very different, or?
Yeah, have you found yourself like putting in the CI logic itself, like, oh, like a check for the mirror is down, or that some software on the system you depend on has been updated, or something like that?
Yeah, I don't really know how to do that, to be honest. Like within the framework that we're living in, right?
Right.
So we would, we need to report it somewhere. So right now, everything that we are seeing is somewhat through GitHub. And like certain GitHub mirrors don't necessarily make that easy. So, sure. For example, like for let me get back to the Sandia CI, because that's pretty sophisticated. There are a bunch of steps that run, of course. And so where we see, okay, like you're authorized to run that, but then also like, can you connect to the service? You see that fairly easily. But I don't know if there's a good solution for running any checks outside of this pull request testing cycle. That would be nice, maybe.
So I have a whole bunch of questions. I'll catch you at lunch.
Go ahead.
But just a couple, one quick question, one quick comment. So what's the actual release process as opposed to just committing PRs?
We're releasing every 4 months.
Okay, so there's actually a process for merging into a release and before, okay.
Yes, we kind of feature freeze right before the release and have dedicated branches for that, and we tag that, and then we remove the branches again.
Okay. Well, and also the comment is, it sounds like there's a lot of drudgery, endless, mindless tasks to monitor all these jobs to finish. And so it sounds like, and I'm going to be that guy, it sounds like it's perfect for an AI agent.
Yeah, it could be.
Well, I make that comment because I've been using one. Claude's just great for monitoring CI. It can fix things when it finds errors.
Yeah, again, it's a question how to tie it in. Maybe we haven't really gathered much experience with AI in general. Like we tried, of course, to gauge general usage in like pull requests, but then it would be interesting to see if that can help. What we always need to figure out is build failure caused by infrastructure, or is there like a real issue?
It's great for that. Yeah, I'll catch you at lunch. I'll catch you.
I guess so.
So you mentioned that you're running different tests, like for your like nightly builds versus your PR builds. How do you decide which tests you run in each category?
No, we don't. We run the same tests. It's just different configurations.
Okay. All right. That explains that. And then second question is for the nightly builds, if the nightly builds fail but everything else looks good, how do you, like, as a culture in your team, how do you like make those failures obvious to the team members that would need to fix it?
Yeah, that's basically where we rely on members of the CI working group to monitor that. But that's somewhat difficult for us to immediately spot.
Okay, thank you.
So a little earlier, you'd shown a pie chart with all the different institutions running the different nightly builds. And so I'm curious, so do those tie back into that C- dashboard, or is that more so defensively they're just trying to find bugs within their entire application stack, and they sort of decide if they run into issues, how they report back to the Kokkos, project, or like? So do you have insight into those institutions' nightly builds, or are there sort of complexities with trying to feed back their CI results, I suppose?
Yeah, I mean, all the nightly builds are reporting back to the nightly C-, basically, and we are only testing Kokkos there, so there are no other applications reporting. But the idea being that the institutions test configurations that matter most to them.
Right, okay. Which is only a limited number of people can see. So
No. This is open. This is on my.c-, so that's maybe also like a great resource. You can just create a dashboard there. You don't. I mean, you don't need to pay anything for hosting that as of now. So that's
okay.
really nice to do. Yeah.
Okay, thank you.
So I can give you some hopefully positive news. We are inching closer to the Trilinos results being able to be sent to my.c-org directly.
Yeah.
I don't want to promise a timeline on that because we know how that goes, but
Yeah.
it's very close, hopefully. I wanted to ask, it sounds like most of your CI builds, I'm getting the impression based on how you do monitoring and subjective analysis of it, are they all required to pass? Do you have sets that aren't or are required to pass, or is it all informative and you make a qualitative decision on the core team side before you merge a pull request?
I mean, I don't know what the exact settings are because I can't merge things anyway. But in practice, it's a judgment call. Like it's rare that we have like all green situation.
Okay.
So
Yeah. No, that's exactly what I was asking. 'cause
Yeah. That's our.
We tried to take the hardline approach on the Trilinos side and say, if it's accepted, we guarantee it works. We don't bypass it. Which makes you much more susceptible to system problems then, right? Because, as you said, if you have multiple sites and you have a problem at one site, then nothing gets in until that problem is fixed. And that's the approach we've taken, but...
Yeah. I mean, that's exactly like our redundancy. The redundancy means we are okay with ignoring some failures because we know that the configuration is covered elsewhere, and if we see that, like...
But you do that subjectively as a judgment call on the team side. Okay, thank you.
Okay, thank you. I think we're done with questions.